The Origins of Artificial Intelligence is the Dartmouth Summer Research Conference held in August 1956. The goals of the conference proposed by Claude E. Shannon, Marvin L. Minsky, Nathaniel Rochester, and John McCarthy was to study a wide range of topics that included complexity theory, neural nets, and creativity and randomness. Marvin Minsky stated in the original proposal that an intelligent machine would tend to build up within itself an abstract model of the environment in which it is placed. If it were given a problem, it could first explore solutions within the internal abstract model of the environment and then attempt external experiments. What does this mean? It means that an intelligent machine or human being constructs an internal representation of the world, how it works, what it does, and it is there where it first attempts to solve a problem by making a plan or strategy before taking action.
Because in order to move in the world, in order to control it, in order to also recognize the movements of another, you need to have some sort of model of your own body.
Right.
And the way that the model is going to be built up is that the robot is doing actions and watching itself.
AI research depended upon representational knowledge and deliberative reasoning methods for the next 30 years. This was the basis for robotic planning and defines the classic AI methodology as the ability to represent hierarchical structures by abstraction and using knowledge that utilizes symbolic representational assertions about the world. This representation would be essential to robots demonstrating human intelligence. One of the first demonstrations of classic AI approach to robotic intelligence and planning was the Shaky robot constructed in the late 1960s at Stanford Research Institute.
At SRI, we are experimenting with a mobile robot. We call him Shaky. Our goal is to give Shaky some of the abilities associated with intelligence, abilities like planning and learning. Even though the tasks we give Shaky seem quite simple, the programs needed to plan and coordinate his activities are complex. The low-level actions provide some of the building blocks for more complicated and powerful programs called intermediate-level actions. One such action is go-to. Go-to plans and executes a route to a named goal location, marked with a cross here, circumventing obstacles if need be. The go-to program plans a route by first computing whether any obstacles lie on a direct path. If so, points near the obstacle are set up as sub-goals. After Shaky computes a route, he traverses it to the goal.
With behavior-based bio-inspired approach, as stated by Rodney Brooks, planning is just a way of avoiding figuring out what to do next. He claimed that intelligent behavior is generated by the direct coupling of perceptions and actions. It does not invoke the mediation of high-level cognitive processes such as representation and reasoning. Behavior-based approach focuses on complex appearing behaviors with little internal variable states to model the immediate environment, where there is mostly gradual corrections to actions via sensory motor links until a desired result is accomplished. This is trial and error. Gray Walter in 1950 devised and built a series of mobile robots to demonstrate that complex and purpose-driven behavior could emerge from a set of simple interconnected devices embodied in a situated organism. These shelled, low-speed turtles were considered the first autonomous robot. Owen Holland recently reconstructed the turtles and stated that these robots displayed complex, unpredictable behaviors such as discrimination, exploration, and adaptation to a changing environment. Today, behavior-based bio-inspired is considered by some the new AI. They resemble living organisms with better agility and flexibility, and novel functionality. But what is the nature of these behaviors? Behavior-based bio-inspired and classic AI represent two different approaches to programming robots. The first is to build simple robots in natural environments. The second is to simplify the environment and build complex reasoning systems for these simple environments.
Okay, right, you tell me what
Both have their advantages and challenges. With behavior-based, the environment is natural, the type of environment we live in and the one we want a robot to operate in. These robots may be flexible, but the tasks are simple. With the classic AI approach, the environment is simplified but the robot is optimized for particular situations which require a model of the robot and its environment. Comparing behavior-based bio-inspired and classic AI approaches to programming robots is the goal of this challenge.